So good morning student. Previous class we have discussed about linearity property, time reversal property, time scaling property, duality property or symmetry property and examples of that properties. In this class we are going to discuss about continuation of previous class, that is Fourier transform properties continuation. The next property is time shifting property. So what is the time shifting property? What is the time shifting? X of t is the signal. How to represent time shifted signal? X of t plus or minus t naught. Where t naught is an integer. If t naught is the positive value, then the signal will be shifted towards right direction. If t naught is a negative value, then the signal will be shifted in left direction. So this concept already discussed in first unit. So now here prove that time shifting property of Fourier transform. So what is the statement of time shifting property? If Fourier transform of f of t is f of omega, then the Fourier transform of f of t minus t naught is e power minus j omega t naught into f of omega. Okay, so that is a statement of time shifting property. If f of t has Fourier transform f of omega, then the Fourier transform of f of t minus t naught is e power minus j omega t naught into f of omega, where t naught is the shifted amount. Where t naught is the shifted amount. That is the statement. So now prove the time shifting property. We know that the Fourier transform of f of t is given by f of omega, that is equal integral minus infinity to infinity f of t into e power minus j omega t dt. So that is definition of Fourier transform of a signal. Definition of Fourier transform of a signal. So now here we want to prove that Fourier transform of f of t minus t naught. So using definition of Fourier transform of a signal, similarly, the Fourier transform of f of t minus t naught is integral minus infinity to infinity f of t minus t naught into e power minus j omega t dt. Okay, let t minus t naught is equal to another variable. Consider another variable. So let us consider t minus t naught is equal to x. X is equal to t is equal to x plus t naught. Minus t naught is going to RHS side. We have plus t naught. T is equal to x plus t naught. Where t naught is the constant, integer. Differentiating with respect to x, dt is equal to dx. In previous equation, what are the ranges of t? T ranges are minus infinity to plus infinity. Here we are considering t minus t naught is equal to x, t is equal to x plus t naught. So now calculate ranges of x. If t is equal to minus infinity, then x is minus infinity. If t is equal to plus infinity, then x is equal to plus infinity. The ranges of x is also minus infinity to plus infinity. Therefore, from previous equation, Fourier transform of f of t minus t naught is equal integral minus infinity to infinity f of t minus t naught. So now here t minus t naught is considered as small x. F of x into e power minus j omega t naught. So t minus t naught in that equation, t is equal to x plus t naught. E power minus j omega into x plus t naught into dt. dt is equal to dx. So this exponential term is split into two terms, that is e power minus j omega x into e power minus j omega t naught. So that is equal integral minus infinity to infinity integral minus infinity to infinity f of x into e power minus j omega x dx. E power minus j omega t naught is written before integration. So using definition of Fourier transform. So what is the definition of Fourier transform? Fourier transform of f of t is f of omega, that is equal integral minus infinity to infinity f of t into e power minus j omega t dt. So using definition of Fourier transform, here what is RHS integral term? Integral minus infinity to infinity f of x into e power minus j omega x dx. So using definition of Fourier transform, what is this integral value? Fourier transform of f of x. Fourier transform of f of x is f of omega. Okay, so this integral value is f of omega. That is equal Fourier transform of f of t minus t naught is equal e power minus j omega t naught into f of omega. So this is very important property. Keep in mind. The Fourier transform of time shifting property is very important. What is the Fourier transform of f of t minus t naught value? E power minus j omega t naught into f of omega, where t naught is the shifted amount. The t naught is the integer value. So similarly, Fourier transform of f of t plus t naught is e power j omega t naught into f of omega. Next, find the Fourier transform of the waveform shown in figure. So this is the given waveform. Calculate Fourier transform of a waveform shown in figure.